Antarctica is the southernmost continent on Earth, located almost entirely within the Antarctic Circle. It is the fifth largest continent, covering around 14 million square kilometers, about 5.4 million square miles of ice-covered land. Antarctica is known for its extreme cold, with temperatures reaching as low as -89 degrees Celsius, -128.6 degrees Fahrenheit, making it the coldest place on Earth. The continent remained undiscovered until the early 19th century. The first confirmed sighting of Antarctica is often attributed to the Russian expedition led by Fabian Gottlieb von Bellingshausen and Karl Lazarev in 1820. Climate change. Antarctica is experiencing some of the most rapid warming on the planet. This has led to the melting of ice shelves, loss of sea ice, and changes in wildlife habitats. Melting ice contributes to global sea level rise, posing risks to coastal communities worldwide. Ozone depletion. The Antarctic ocean hole, discovered in the 1980s, remains a concern despite international efforts to reduce ocean depleting substances. This hole increases ultraviolet UV radiation reaching the Earth's surface, impacting marine and terrestrial life. Environmental pollution. Despite stringent regulations, human activities in Antarctica can lead to pollution. Waste disposal, accidental spills, and introduction of invasive species can disrupt the delicate Antarctic ecosystem. Microplastics have been found even in remote parts of Antarctica, highlighting global pollution issues. Scientific and resource exploitation. There are concerns about potential exploitation of Antarctica's mineral and biological resources as technology advances and climate change affects accessibility. Balancing scientific research with sustainable management of resources and protection of the environment remains a challenge. Logistical and operational challenges. Operating research stations in Antarctica requires significant logistical support, including transportation, supplies, and infrastructure maintenance. Harsh weather conditions, including extreme cold, high winds, and months of darkness during the polar winter, pose operational challenges. International governance. The governance of Antarctica is complex, with overlapping territorial claims, although these are mostly suspended under the Antarctic Treaty System. Ensuring compliance with environmental regulations and maintaining peaceful cooperation among nations with research interests in Antarctica requires ongoing diplomatic efforts. Addressing these challenges requires international collaboration, sustainable practices, and continued scientific research to understand and mitigate the impacts of human activities and climate change on Antarctica and its global significance. Antarctica is experiencing significant changes due to climate change, but describing it as dying might be overly dramatic and not entirely accurate. Ice loss. Satellite observations and scientific studies have documented the thinning of Antarctic ice shelves and the acceleration of ice flow into the ocean. This ice loss has implications for global sea level rise, but it's important to note that the majority of Antarctica's ice sheet remains intact. Environmental changes. Changes in temperature and ice cover affect Antarctica's unique ecosystems, including wildlife such as penguins, seals, and krill. These changes can disrupt food chains and habitats, impacting the biodiversity of the region. Scientific understanding. Scientists continue to study Antarctica intensively to understand the dynamics of ice sheet stability, ocean circulation, and climate processes. Predicting future changes and their impacts on global climate requires ongoing research and monitoring. While Antarctica is undoubtedly undergoing significant changes, it is more accurate to describe it as a region experiencing rapid environmental transformation due to human-induced climate change rather than as dying. Efforts to mitigate climate change and protect Antarctica's fragile ecosystem are crucial to preserving its scientific value and environmental integrity for future generations. Antarctica holds profound importance for both scientific research and global environmental stability. Climate science. Antarctica plays a critical role in regulating Earth's climate. It stores about 70% of the planet's fresh water in its ice sheets. Studying Antarctica helps scientists understand past climate change through ice core samples and current climate dynamics through ongoing monitoring. Sea level rise. The Antarctic ice sheet is the largest single mass of ice on Earth. Monitoring changes in its mass helps predict future sea level rise, which directly impacts coastal communities around the world. In summary, Antarctica is invaluable for its contributions to climate science, biodiversity research, global environmental health, international cooperation, and educational outreach. Protecting Antarctica and studying its changes are essential for understanding and mitigating the impacts of climate change on a global scale. If all of Antarctica's ice were to melt suddenly in just one day, it would result in catastrophic and unprecedented impacts on a global scale. Here are some of the potential consequences. Sea level rise. The Antarctic ice sheet contains about 70% of the world's fresh water. If it were to melt completely, it would raise global sea levels by approximately 58 meters (190 feet). Even a partial melting over a short period would lead to massive sea level rise, inundating coastal cities and low-lying areas worldwide. Hundreds of millions of people would be displaced, and infrastructure worth trillions of dollars would be lost. Coastal flooding. Major coastal cities such as New York, London, Shanghai, and many others would be underwater or severely affected. Entire island nations could disappear, leading to a refugee crisis and unprecedented humanitarian challenges. Disruption of ocean currents. The massive influx of fresh water into the oceans could disrupt ocean currents and circulation patterns. This disruption would affect global climate systems, potentially leading to altered weather patterns, including changes in precipitation, temperature, and storm intensity. Impact on biodiversity. Antarctica's unique ecosystems, adapted to extreme cold and ice-covered conditions, would face complete destruction. Global climate feedbacks. Antarctica's ice sheets reflect sunlight back into space, helping to regulate global temperatures. With the loss of this reflective surface, the Earth would absorb more solar radiation, leading to accelerated global warming and further melting of ice in other parts of the world.